Standard 6.2 Criterion 20. Manage the use of technology for learning in a non-traditional classroom setting. Manage the use of technology in student learning strategies and digital platforms, virtual environments, hands-on makerspaces, or in the field. My AV Tech 1 and journalism classes managed the use of technology and student learning strategies in digital platforms, virtual environments, and hands on or in the field of makerspaces. We also applied technology for learning in the classroom, blended learning, hybrid learning, and online learning environments. These classes required a combination of skill sets.
Short-legged wires. I used two alligator cables and it worked fine with the blinking lights. But that's a problem I had to solve because my two short legs did not meet.
The criteria focused on learning strategies for managing the use of technology in a non-traditional classroom setting that enhanced learning. Students experimented with the Bebot, which was a fun piece of digital technology, as they each programmed it to complete the program task. Videotaping the lesson provided a virtual environment for others when we posted it online. I visited 3 makerspace venues to share photos and videos with my students to help them brainstorm creativity with their projects. These locations were Geek Space Gwinnett in Duluth, Kennesaw State University Makerspace, and Decatur Makers in Decatur, Georgia. I shared with students the possibilities of other forms of education after high school, like makerspaces, online jobs, and other non-traditional classrooms. There are other forms of digital learning, like podcasts.
Welcome to my podcast, Kozer's Corner. Today we will discuss how to interview your teacher, which will cover one of your required instructional units.
Other digital learning is digital storytelling, breadboarding, and coding. AV Tech 1 managed the use of technology for learning in several non-traditional classroom settings. Student learning strategies were implemented in digital platforms, virtual environments, hands-on makerspaces, and in the classroom. Create opportunities for students to use a design process and computational thinking. Create learning opportunities that challenge students to use a design process and computational thinking to innovate and solve problems. Journalism and Audio Video Technology and Film 1 class created a learning opportunity that challenged students to design a process which was a code for a Bebot to get from point A to point B. Design and computational thinking are powerful competencies for problem solving. Building those skills require designing and implementing activities and opportunities for learners to gain practice. Students were able to design the process and use computational thinking to innovate and solve the Bebot problem. Computational steps to organizing student design process was writing the code and directions and creating a bot map. The student used construction paper, scissors, glue, and a ruler. Students used computational thinking as they worked together to design their bot map. Here are photos of students working together. Students were testing their program with the bot on the master mat.
Now we turn to the left, forward, forward, turn right, forward, forward. That's where we're at.
So now,
Through the coding and bots, students created a learning opportunity that challenged students to use a design process and computational thinking to innovate and solve problems. After several attempts in rewriting the program, students had success in the bot going from point A to point B.
Forward, forward, left, forward, 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 right, forward. Okay, alright, we're running. Okay, done. That's done. That's done. That's done.
Yeah!
Standard 6.4, Criterion 22. Model and nurture creativity. Model and nurture creativity and creative expression to communicate ideas, knowledge, or connections. Artifact 11 displays how the instructor modeled and nurtured creativity and creative expression to communicate ideas, knowledge, or connections. The students creatively expressed and modeled their grids and bots after making a 4x4 grid for the B-bot. The teacher initially modeled and communicated ideas of how to write code and get the B-bot from point A to point B. Students collaborated to write their program any direction for the bot to reach its destination. Students divided into pairs and wrote their programs.
So right now you should have one, two. So you're right there, right? Forward, forward, left, then up here.
Students created a checkerboard model similar to the 4x4 grid sample. After practicing the bot trip, students will test the bot based on the written
You
directions.
hit reset.
90-degree turn to the right. Forward, forward, left, forward, right 90. Forward, forward, left, forward, forward, right, forward, forward, left, forward, 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 right, forward. Okay, alright, we're running. Okay, done. That's done. That's done. That's done.
Yeah!
Adjustments were made if there were errors, and then students redid the pathway until successful. Students developed creativity
Take a
and
two.
communication through correcting their coding.
3.
That's 3.
Special needs students and English learners got involved. The projects were showcased in the classroom with student peers giving positive feedback. The instructor modeled and nurtured creativity and creative expression to communicate ideas, knowledge, or connections to the students. The class enjoyed the challenge, which promoted their creativity and communication.